All right, in number 7 here, it says, if an archer shoots an arrow straight upward with an initial velocity of 128 feet per second from a height of 6 feet, then its height above the ground in feet at time t in seconds is given by this function. H of t equals negative 16t squared plus 128t plus 6. What's the maximum height of the arrow? And after how many seconds does the arrow reach its maximum height? So we know we have two variables here. Our height is h of t, and of course t is time in seconds. And so this graph, actually before I get into the vertex formula here, whoops, let me go backwards. Basically, if you were to graph this parabola here, that's quadratic equation or function, so we're going to have a parabola that opens down since you have the minus out front. So at this point right here you would have a maximum value, so this makes sense. And where are you going to find that? At what we call the vertex, that point there. So we use the vertex formula, and normally it's x equals negative b over 2a, but notice our input here is t, and t stands for time. And so let's go ahead and plug in our numbers. You can see that b here is 128. So we have negative b, or negative 128, over 2 times a, which is negative 16. So this will be negative 128 over negative 32, and you should get 4 there. Now that's our time. And notice that's going to be what we're looking for in part B. After how many seconds does the arrow reach its maximum height? Well, that's after 4 seconds. To find the maximum height, we actually have to put the 4 into the function. So we want to find h of 4. So let me go ahead and plug that in here. And you can put this into your calculator, and you should get 262. Now we're working in feet here, so this will be 262 feet. So all we've really done is found the vertex of this parabola. Whoops, put it in a bad spot there. So it's 4, 262, and we know that the maximum value for a function will always be the y value of the vertex. That's the 262 here. And again, the first value there, the 4, that was our time. All right, let's move on to number 8. So we're supposed to find the equation of this circle. Well, we have a formula for the equation of a circle, which you were given. And notice HK is what we call the center of the circle. And in this case, R, or our radius, is 6. And so I'm just going to plug these numbers in. It'll be x minus h, or x minus negative 4 squared, plus y minus k. In this case, k is negative 3. So notice we are subtracting negatives here. Be careful there. And 6 squared is going to be on the right. So x minus negative 4 becomes x plus 4 quantity squared. And we'll get y plus 3 squared in the middle there, and then 36 on the right. And that's all we have to do there. All right, on number 9, we have to find the inverse of this function. So there's 4 steps that we find. So let's go ahead and write the steps as we go. Number 1, we're going to replace f of x with y. In fact, this step and the last step are just notation steps. It's easier to work with y than f of x when you're manipulating an equation. So now the key step, the next step, would be to switch the x and y values. And so let's go ahead and do that. I guess if there were another key step, it would be to solve for y at this point. So we need to get y by itself. Now you could subtract 3 first, but I think I'm going to go ahead and clear fractions by multiplying by our LCD, which is 5. We're going to get 5x equals, let's see, the 5's cancel here, you get y, plus 15. And so let's subtract 15 on both sides. We're still trying to get y by itself. And we're going to get 5x minus y, or 5x minus 15 equals y. And let's go ahead and switch the sides here. And don't forget the last step, we're going to want to replace y with f inverse of x, which was what we were asked to find. And so we're done. Now it does say to graph, so I'm going to go ahead and graph f of x first. Let me put a little graph there, and so our y-intercept here is 3. So 0, 3 is on the graph. It's a little bit hard to see there, but you'll see that blue dot at 3. And then our slope here, remember this is actually what we call slope-intercept form, y equals mx plus b. And so in this case our slope is the number in front of x. In this case this is just a 1x, so really it's 1/5 x. So the slope is 1 over 5. And so we would rise 1 and run 2. So go up 1 and go right 5. Up 1, right 5. When you do that, you end up at the point 5, 4. So be careful as you do that. Up 1, right 5. You end up at 5, 4. So here's our line for f. Now, finding f inverse, we could graph fx minus or 5x minus 15. But it'll be easier to just switch the points of f. So 3, 0 and 4, 5s. Since 0, 3 is on f, that means 3, 0 is on the inverse. And the same thing with the 5 and the 4. We just switch those to get 4, 5. And when you plot those points, you can see that that would be the graph of f inverse. And one way to make sure that you've done it right is to draw y equals x. And you should have symmetry through that line, which we do. All right, let's move on to number 10. So we're using the same 4 steps on number 10. Let's go ahead and change to the y notation. And if I'm trying to solve, or actually, I'm sorry, we need to switch x and y here first. Excuse me. If I'm trying to solve for y here, I really can't get inside the radical and unless I get rid of that cube root. I can't like add 8 to both sides at this point. I need to get rid of the radical. And so we need to recall, and how do we reverse taking a cube root, or another way to say it is, what's the opposite of taking the cube root of a number? And that would be cubing. So we're going to cube each side. So on the left we have x cubed, and on the right we're going to have y minus 8. I'm just going to go ahead and switch the order here because I want to solve for y. So y minus 8 equals x cubed. And now I need to add 8 to both sides, and we get y equals x cubed plus 8. And then last thing, don't forget we got to change notation back to the inverse, or the function notation. In this case we now have the inverse function, which is what we were supposed to find. Now we need a graph here. So I'm going to go ahead and graph the cube root of x minus 8 first, but let me go ahead and put a grid here. Now, you would recall that the cube root function, it's one of our parent function. It looks something like this. I call it a sideways John Travolta. And but the only thing is, because of this minus 8, we're going to have a horizontal shift, so we're going to have to go right 8. So let's go ahead and move that graph right 8. Let me go ahead and erase here. So it's going to look something like that. And I can do the same thing with x cubed plus 8. Now I could just use these points, the 3 points we have here, and switch the x's and the y's, and that's another way that you could find the points. But on this one here, x cubed is one of our parent functions. We know that looks something like that. And so I'm going to just move that graph up 8, and it looks like that. And again, we should see symmetry through y equals x, and notice we do. All right, let's look at number 11. We're investing $3,225 into a savings account that earns 3.5% interest compounded semi-annually. That means we're not going to be using PERT. We'll be using our other formula, but notice also that n is going to equal 2, And so we're using this formula with n equals 2. This is the formula we use when we compound interest in times per year. Remember, a compounded interest is just when you're earning interest on interest. And so right now, though, we just need to identify the different parts. So we invested $3,225. That's our principal, or our P. The interest rate is 3.5%, so we would want to write that as a decimal. Move that decimal 2 to the left, and you get 0.035. And notice it says on part A, how much would you have in the account after 22 years? Well, that means T is 22. So what we're looking for is A here, the amount we're going to have in the account after 22 years. A is for amount. So let's plug in our numbers here. P is 3,225, R is 0.035, and N is 2. And that'll be 2 times 22 on the outside there. Now, really, when you put this into your calculator, you should be putting it in pretty much like it looks. 325, parenthesis, 1 plus 0.035 divide 2, into parenthesis. Don't forget you're going to need to use your exponent button here and either use 44 or 2 times 22 inside parentheses. So when you do that, you should get $6,919.01. Now in part B it says how much interest would you have earned in those 22 years? Well, what we're going to want to do is subtract what we started with, our P amount, and that should give us the amount of interest that we've earned. Alright, let's go on to number 12. So it says here it says how much would you need to invest today at 2.1% annual interest compounded continuously. So notice we are going to be using PERT here, the PERT formula. So you would have $2,000 in your account at the end of 5 years. So let's go ahead and write our formula out and let's find the numbers here. So it says how much would you need to invest? So we're looking for P here. At 2.1% interest, we're going to write that as 0.021. Notice A is 2,000 because that's how much is going to be in the account at the end after 5 years. That would be our oops, I said R equals 5. Let me fix that. Should say T equals 5. All right. So let's plug in our numbers. A is 2,000, R is 0.021, and T is 5. And so we're trying to solve for P. So let me first multiply in the exponent there to simplify things a little bit. You should get a 0.105. And now if we're trying to solve for P, you've got to get P by itself, and it's P times e to the 0.105. We need to divide by e to the 0.105. And so P is going to be 2,000 divided by e to the 0.105. And when you put that into your calculator, you should get $1,865. $1,800.65. Let's see here. I was going to add something, but I guess I don't need to add it because I forgot what I was going to say. So let's move on to number 13. It says use the properties of logs to rewrite each expression as a single log. We call this condensing. It says condense it here. The first thing I want to do is write down our properties to remind you of what they are. So there's our product rule, quotient rule, and the power rule. And you need to know these. And we're going to label these 1, 2, and 3 so that when we use them, I'll put the number so you know which one I'm using. And I think I'm going to do B first because it's a little more easy, or a little simpler. So here we have a subtraction of 2 logs. Notice we're going to need to use property 2, which says the log of a quotient, m divide n, is equal to a difference of logs, or 2 logs subtracted. So when we have 2 logs subtracted, we can turn that into 1 log, and these numbers here, the m and the n, they just get divided, and the first one that comes is in the numerator and the second one in the denominator. And so in this case, we're going to have the log, so we're using property 2. We'll have the log base 4 of x over y. So that's all we had to do. Now on part A, notice the 2 here and the negative, or the half here. I can't use any of the, well, either of the first 2 properties because of that. So property 1 and 2 are out as possibilities right now, because if you look at here, these are all 1s. And so the first thing we need to do is get rid of that 2 and the 1/2 there. And so we're actually using property 3 first, which tells us, so basically we have a number out front, we're going to move that to be an exponent. And so we'll go ahead and move the 2 to be the exponent on x, and the 1/2 to be an exponent on 9. So this is, we're using property 3. So the natural log of x squared, we'll just rewrite the middle log, and minus the natural log of 9 to the 1/2 power. Notice we have a sum of 2 logs to start here, and so we can use property 1, because we do have 1s here now. And so we can put x squared and y together using multiplication, and we get x squared y, so we've made it into a single log. We still have the minus natural log of 9 to the 1/2 power, and I would remind you that anything to the 1/2 power is equal to a square root, and so this is just the square root of 9. And so now we have a subtraction of 2 logs, and so we can use property 2. And I didn't even write it up here. Let me go ahead and put that there. And oh, I'm sorry. You know what? I know what I did wrong there. Hold on a second. Let me go back. All I did here is take the square root of 9, and that's 3. And so now we're ready to use property 2. So let's go ahead and do that. And it'll be the natural log of x squared y over 3. Alright, let's move on to number 14. It says use the property of logs to expand the given expression as much as possible. So for both of these, we have a single log, and we need to expand it into 2 or more logs. And we expand as far as we can go. So in this first problem, we have an exponent. We could write that square root of y as y to the 1/2 power. And we also have products there, 4 times x squared times square root of y. So we're going to need to use property 1 and 3. We can't actually use property 3 yet because we don't have just a single base to a power. So let's go ahead and write this as a sum of logs using property 1. It would be log base 2 of 4 plus the log base 2 of x squared plus the log base 2 of y to the 1/2 power. I'll go ahead and rewrite that. Now if you look at the log base 2 of 4, hopefully you see something there. In fact, we can evaluate this log because remember, a logarithm is an exponent. In this case, it's the exponent you put on a base of 2 to get 4. So basically this is what we're doing in our head. 2 to the what power gives me 4? And so that would be 2. And so this log is just equal to the value 2. On the second one there, we need to use property 3 here and move that 2 out front. So let's do that. And then on the last one, we're going to do the same thing. We'll move the 1/2 out front, and we get plus 1/2 log of y. So what you notice here is we're taking the log of a single value here, and when you expand, that's what you want in the end. You should have no exponents on those numbers. All right, let's look at the other one. Now here you can actually use all three of the properties, but again there's only one of them that you can use first. You can't use the product rule because even though you have a product here, you can't just ignore the denominator there. So we can't use the product rule first. You can't use the power rule because we don't have one base to a power, and so we're going to have to use the quotient rule. And so this will be the log base a of our numerator, and notice I'm going to change that to y to the 1/3 power. Remember, whatever your root is, in this case it's 3, that's going to be the denominator of your fraction. And then that'll be minus the log base a of x. So now notice here in this first one, we have a product, so we can use the product rule. That's rule number 1, and break that into 2. So log base a of a to the 5th plus the log base a of y to the 1/3 power. And then I'm just going to rewrite that last log. And then now we should be able to use property 3 to move those exponents out front. And so we'll get 5 times the log base a of a plus 1/3 times the log base a of y minus the log base a of x. And again, notice what we have here is just single values with no exponents. And so that's what we wanted. However, there is one other thing here that we've got to watch out for. Log base a of a, that's actually another logarithm that we can evaluate. So let's do that. So what exponent do you put on a base of a to get a? Well, that's just 1, so that's equal to 1. So what we have here is 1 times 5, which is 5, and then I'll just rewrite the rest of the problem, and that'll do it for that problem there. And in fact, we're going to stop the video here.